one correction on the intro. I am not going to say, how are we going to secure AI? That's like a huge loaded claim. No, we're going to talk about some techniques that we can use and take a trip back to the future and to the past and forward to talk about what are the techniques that have been used in the past. So LLMs, security in the next 45 minutes. This is not a debate about whether AI is here to stay. There's also no silver bullet, at least right now, to securing LLMs. Back to what I was saying before, we're not going to walk away and say, oh yeah, we've got everything nailed, right? There's just a few things that I think we can draw on from the past and kind of apply them to the current state. And that's what we want to explore. What are the security techniques that we know that we've used in the past for enterprise security, for network security, for a wide range of other use cases, and how do we apply them in the current state? And the teaser to that, it's APIs, right? How do we insert at the API point? What are the services we can use to help solve this problem? So that's what we're going to get into. So first, security concerns around LLMs. There is a really, really good paper written by Caleb Sema in a presentation. I would definitely recommend Googling it. I have the link there. I have it in the resource sections as well. Did a great job of just covering a lot of the different attacks. He cited 92 different named attacks that are currently known in attacking AI and LLMs. Again, we're not going to cover all of them. There's a few listed there on the left-hand side, and we will talk about some of them and what we can put in place to help mitigate the risk associated with those. Also, back in, I think it was June or July, and there probably were some contributors in this room, OWASP published the top 10 for LLM apps. This was an awesome write-up. If you haven't seen it, definitely take a look. There's a lot of overlap between those resources that I just cited. So what we're going to do is we're going to take a trip back, right? We want to go, first, show of hands. How many saw Back to the Future 2? Cool. All right. I did this talk before, and at like a local, I'm from Pittsburgh, Pennsylvania, did it local, and nobody really raised their hand, but I think they were embarrassed too. I don't think many people want to admit seeing it, but it's an awesome movie. I loved it. One of my favorite parts in that movie was that whole concept of the alternate 1985, where Marty showed up in this like new reality that was completely warped because of something that had happened in the past. And when Doc Brown charted it out and he said, no, we're living in this alternate 1985 because of those things that occurred from the almanac. If you all remember that part of the movie where Biff made all the gambling and made all the winnings and just kind of everything got warped in the current 1985. Doc Brown said something that I think is relevant here. He said, our only chance to repair the present is in the past. And that's when they have to go back and there's like multiple versions of themselves in 1955. Anyhow, we're going to talk about that in the context of security. I'm going to have Easter eggs too. So if this is boring, at least you can watch different scenes of the movie to keep yourself interested. Okay, so what security tactics can we use and how do we use them? There are a few things that, and I'll overlay some of these on top of that OWASP top 10 at the end, but things like data classification and filtering we can use in the interplay between all the different components as it relates to LLMs. Identifying threats that are exchanged in the content that's moving back and forth between these objects is something we can also do. Secure audit logging. I know that we're all aware that that's really important for applications, for infrastructure, but we need to log everything as much as we can. Who's training what, who's submitting what prompts, where's it coming from, what was the actual content that was exchanged? Those things are really important. Is there a way that we can use digital signatures in the interactions to validate the content and the original author of the content that are being exchanged? Strong authentication and strict access controls are things that we've used in every context of security, so that should naturally apply here as well. So we'll talk about those. Common LLM integration. This is a extremely high level view. I know that there are many more components than this, but just to try to simplify it down to a few key points so that we can start to wrap our heads around where we can insert security. We have user prompts and developer prompts that end up hitting the APIs that are front-ending these LLMs. There's an orchestration layer that usually sits between that and things like other plugins or vector DBs. LangChain's a really popular one here. On the AI API side, OpenAI and a chat interface like ChatGPT are the common ones that we always see. So when we think about what are the insertion points, what can we do here? At the company I work for, Pangea, we focus on building security APIs, and so we're not looking at building a AI security solution. We just look at what are APIs that are relevant to the security space that people can use. So this is a relevant use case. We've been putting some thought into this of how can we help with the APIs that we're building or partnering with, or other open source APIs that are out there. How can it just help this effort? So things like embedding threat intelligence lookups. When we are interacting with a chat interface and getting data back from that chat interface, there can be things like malicious domains or malicious URLs within that, if that data has been poisoned or manipulated in some way. So how do we intercept that information or intersect with it and run threat intelligence against it so that we can sanitize the information coming back to the user? These are things that we would do in any other security context. If you think about things like web proxies do this for enterprise users going out to websites, right? So like, why couldn't we take that same methodology and apply it in this context? Data classification and filtering to ensure that sensitive PII or other sensitive information isn't being accidentally or intentionally provided to these components. Same idea. We can intersect the interface, look at it, and ensure that things like social security numbers aren't being leaked in one way or another. Providing strong authentication so we know who's interacting with each of these components are really important. Fine-grained access controls. So more than just like a role-based access control, but looking at things like even like time of day access or tenure of an employee at a company. We can look at attributes of a user and make a determination as to whether certain interactions are allowed or not. Secure audit logging, I mentioned this before, but really, really important. Making sure that we have APIs intersecting here and logging all of the interactions so that we can understand who's interacting with what pieces of data or what components, and ensure that if something malicious is occurring, we at least have a way to go back and track that, identify it, and correct it. And then I talked a little bit already about earlier about digital signature verification, just having not only the individuals who are interacting with these components verified, but the content signed as well, so that we can ensure that that's not being manipulated as it's traversing any one of these. So the path, the insertion point, and this is like where Doc Brown connects the wire right before the lightning strikes. The security APIs are serving as a wrapper around these. What we've done in a sample app, and it's up on our GitHub page, is we've basically created a very simple chat interface that interfaces with the OpenAI API. And what it does is it inserts the threat intelligence lookups, it inserts the data classification and filtering, as well as the secure audit logging. And it's really, really easy. All we're doing is just looking at the prompts that are coming in, ensuring that they're sanitized. We reformat, or not reformat, but sanitize them, pass them on to the interface. We receive the response back, analyze domains and URLs using threat intelligence lookups, and from there, submit a sanitized version of the response back to the user. So let's take a look at kind of an API breakdown of how this would work. The user submits a chat request to that UI. The chat app itself gets the raw message and passes it to one of our security APIs. In this particular case, it's Redact, but you don't necessarily have to use Pangea. You can find other Redact services as well out there, or APIs. We send back the redacted text to the chat app, and at that point, it submits a PII safe message to the OpenAI interface. That model then processes the chat request, provides a raw response back to the user. Provides the raw response back to the app itself. The user doesn't quite see it yet. The application then provides an added layer of sanitizing to ensure that domains, URLs that are potentially malicious are not passed back to the user. Okay, so we use a domain intel lookup for that. In this particular case, we're using CrowdStrike and domain tools, looking at if that material is malicious, and then we sanitize it and send the final response back to the user. This is a very, very simple use case, but it's a way to show that with APIs, you can plug in at these various layers and add these sanitization capabilities. So if anybody wanted to check it out, I'm going to walk you through elements of a live demo. Unfortunately, my laptop literally died 2 minutes before this this session started. Luckily, my coworker is here with me, and I borrowed his laptop. But I'm going to walk you through a few interfaces. I don't have source code to show you, but if you want to check out any of the source code, you can go up on this GitHub page and check it out. I'm going to jump over to this UI. This is our interface. Again, much of this you can do with other tools if you wanted. What I wanted to showcase was really just the simple redact mechanism. We have this redact API that allows you to basically submit any text. So if I want to submit something like a false social security number, I could put this in and I could send it, and you could see the response back. It redacted the social security number here. Now, where this ends up being used, luckily I ran a few of these before the session, and I can show you what was logged. So if we look at the logs, we can look at this message here, and we could see a few hours ago, I basically submitted this chat message to the chat interface going to OpenAPI. So we have hello from user, and I submitted a false social security number 111-223333. And I say, can you echo the following text exactly? The tag doesn't matter. It's arbitrary. My secret is, and I put a malicious URL. Don't go to this URL. All right. And so what ends up coming back in that response, and again, I don't have the UI to show you because I'm on a different laptop, but effectively that social security number is not submitted to that LLM. Further, the URL that comes back passes through that malware check, and this link is removed. So you can do, when you're doing things like redacting a URL, you can defang it as simply as saying, replacing the T's with HXXP and not making it clickable. Or you could replace the text completely as well. If you wanted to just say malicious domain redacted or something like that, you could replace it with whatever you wanted. But this is again, like a really simple way to demonstrate how we can use these APIs to insert into the different interactions that we have with the AI different components in that ecosystem. So let's jump back into here, and let's look at. I know, it's too funny. Let's look at like what else can we do? Like that's a really, really simple use case, and it demonstrates that APIs can plug into these things. But what else can we do to make sure that other things don't get out of control into this like wild alternate 1985? Okay, so strong authentication and authorization. The auth piece is really, really important. We all know that, but it's often overlooked, or it's a lot of corners are cut. So things like ensuring that all of our interfaces have multi-factor auth, at least associated with them, or even as well as using like passkeys, setting up step-up authentication flows when things are looking suspicious. We need to do that on all of the interfaces that we have to these systems. Again, we all know this, but it's a lot of times overlooked just because of speed of innovation, or it's just we have other things to do. But it's just really, really important when it comes to safeguarding these things. Ensuring that authorization boundaries are not crossed. So who has access to what data, keeping LLMs aligned to the right users, roles, and groups. This is where some of the authorization piece comes into play. This is even more important with plugins. So there's a lot of, even in the OWASP top 10, they talk a lot. I think there's at least 2 different threats that are associated with plugins and how those can go rogue. That's another important thing. If you're bringing those into your environment, ensuring that you have the right authorization boundaries around those, and they're accessing a subset of data or only particular users can get access to them, these things are really, really important. How do you do it? You do it by inserting authorization APIs into that ecosystem. And that's, we're going to talk about it a little bit later, but that's the next step in the samples that we want to build, or how do we take an app like that and start putting authorization checks in line with something like LangChain, right? Where as we're accessing vector DBs, can we do the right permission checks in code to make sure that that's permitted before data's retrieved from that DB or data is returned back to the user? When you start looking at things like authorization APIs, there's a ton of things out there. There are things that we can do, but it's not just Pangea. There's other vendors and there's open source solutions as well. So I would just encourage everybody to look at that and think about how you can incorporate authorization APIs into the flow. And I don't know how familiar you are with authorization, but it's such a fast growing space. RBAC is like the role-based access controls are the classic that we all know. But this notion of attribute-based access controls and relationship-based access controls are growing really, really fast. So I would definitely take time to look at that. I think that the attribute one is really, really important when it comes to inserting these API checks throughout the interaction of all of the components, because again, it allows you to look at things like whether it be time of day or location based, or look at different profile information about users. You're basing it more than just roles or groups. You're looking at details about individuals. So these things are really, really important. And again, something in the sample apps that we put out on GitHub, we're going to be building this out too. Okay, audit logging and verification. So the strong logging piece is, again, I can't underscore the importance of this enough. Being able to insert API calls throughout this that are logging all of this activity are important, but it's more than just saying we're logging. It's how do we ensure that what we're logging is also secure? Because the next step after something happens we all know this, next thing that happens after any adversary gains access to anything is they're going to go to the logging system and try to cover tracks. So using a tamper-proof logging platform is of utmost importance. We want to track not only the source, but also the time of day, the message. You saw some of the audit log details and the ones that I showed you. Following that is a good starting point, but you can get as granular as you want. I think there's a future opportunity here. I relate everything to network security. I started in network security with like intrusion detection, firewalls, IPSs. And so to me, like I always think of things like packets on the wire, and you're inspecting those packets and the content of those. This is kind of no different. It's just the wire is an API. It's a series of calls. So I think there's a future opportunity here for like an intrusion detection or prevention like system for LLMs that are monitoring the messages that are exchanging each of the components. And I don't know if it'll be signature based or something else, but being able to set rules so that you are ensuring that particular words or phrases or categories are not being used in training or trying to poison LLMs. I think there's probably a startup out there working on it already, or a few open source projects. I haven't researched it, but I think there's an opportunity there where you're actively scanning and looking at all of the intersection points and looking for people deliberately trying to poison. So there's something there. And then further, those messages, being able to like digitally sign them. Can we make it easy? Is there a wrapper interface that allows whenever prompts or training data is being fed into these systems, can they be digitally signed? Can we make this very easy? Is there an interface that will automatically do the signing work? So these are things that we're looking at. Again, we're not trying to be an AI security vendor. These are just examples that we're thinking of how to use security APIs in a constructive way for this platform. So back to the security insertion points, I talked about the interface that sits right in front of the security APIs that sit in front of the chat interface. I think the next step, or at least what we're going to be looking at, are how do you put wrappers around this orchestration layer? I mean, I think this is where the real power lies. When you can start integrating into things like Llama or LangChain and put all of these use cases into something like that. There's a shout out to a company, or not a company, a open source project. I think it's called LLM Guard. They're doing things like this, so it looks pretty cool. We've been watching what they're up to and want to collaborate. We're building out sample apps too that will start to demonstrate this. But I think when you start inserting things like attribute-based access controls at that orchestration layer, it gets really, really powerful. And again, the fact that all of these capabilities that we're mentioning that are in the orange and green, things like threat intel lookups, data classification, and filtering, strong auth, FGA, audit logging, all of these are available as APIs now. A lot of these used to be classic like enterprise products that were maybe difficult to consume or not friendly for developers, but now you can find these from a lot of vendors and a lot of even open source tools and easy to integrate via API. So I would definitely, as you're all thinking about this, have those in mind and check them out. Okay, so when we overlay, I was looking at the OWASP top 10 a few weeks ago on this, and just kind of thinking in this context with APIs, what are specific things that can be done in each of these? And again, back to the original disclaimer I put out there. This is not a silver bullet. It's like we're not sitting here saying that, oh, this is the grand answer for all of these things. But these are things that we've done in the past. Authorization checks have been around for as long as security has been. Looking at data and protecting data through redaction, applying threat intelligence lookups, strong authentication. All of these things we know them all. So it's like, why don't we try to find ways to apply them via APIs in these contexts? So again, things like with prompt injection, being able to sanitize the data before it arrives at the LLM, being able to look at who's submitting this and look at the attributes of that individual and being able to apply access control policy on that are I think obvious things that we can do, but they're easy to do now because the APIs are out there to do it. And I think just now people are starting to build examples out on the in the open source community that demonstrate how to bring these things together. So yeah, definitely check these out. Read the top 10. It's interesting. They have recommendations as well on things that you can do. What I'm trying to highlight are that the APIs are there to make this type of plumbing a reality. And sample apps are coming out now for all of these. Okay, so going forward, things I know we'll be talking about in our samples and APIs and things like that as it relates to OpenAI. And this is just a suggestion. It's not saying it's the solution, but it's this notion of a trust framework. And we need to build this out more and work more with the community on it, where we say, okay, access controls, what does that really mean? Like, what does that mean when you're inside of something like LangChain? What are we looking at and what are we preventing? Actually getting down to the demonstration of that and writing a sample app that shows it is the next step. Authenticity, digitally signing the content, going back and forth between these, that's the next step as well. We need to put samples out there for these things. Audit logging is easy to do right now, being demonstrated, as is data protection. So these are things that can be activated right now that are demonstrable code that you can pull down. Access control and authenticity are also achievable right now if you want to write the code yourself, or if there are projects that are out there I'm not aware of. But I know that these things are being worked on, both in open source, and there are startups that are starting to emerge that are doing these things. But it's achievable now. As far as some things that we're working on to contribute to this, these are microservices that are all API accessible from Pangea that we're working on. And they range from secure audit logging and authentication and authorization all the way through to the threat intelligence things that I talked about. I don't want to go through all of these, and we're not the only people who build these and make them available. So if you want to venture out and check out others, please do. Just know that all of these are usable in this context, and they're available today. These are things that you can use with all of the open source sample apps to start layering in those security checks as those components are interacting with one another. Okay, so in closing, I hope that you enjoyed the theme, like the idea that These things have existed for a long time. We just need to find a way to apply them to the new context. And this in and of itself is not an original idea. This is security in general. These ideas have been around for a while. We need to use APIs, and I think that's like the real thing that has changed now. If you think about over the last 5 years or so, all of the security tooling wasn't always accessible via APIs. Now they are. So that as these new technology interfaces and stacks like OpenAI, ChatGPT, and others are emerging, we have tooling now to use them. So if you wanted to check out the open source samples that we've put out there, again, sorry I couldn't demo the code or anything for you live today, but showed you a little bit at least on the back end with audit logging. You can go to our GitHub page and check out the open source samples that we've put out there around this. It's called Secure ChatGPT. Should be pretty easy to find. If you wanted to use any of the APIs that I showed you, the redact or the secure audit log, you can try them on our console for free, Pangea.cloud. We have a great freemium model that allows you to get going for free, and the freemium model renews itself in perpetuity. So you can keep going and going as much as you want. If you wanted more credits, you can use that code, LastCon23. Again, you don't have to use Pangea. If you found other things, that's great too. The point of the session is to highlight these insertion points that we have to start using with APIs to add these security layers within the interaction with LLMs. If you wanted to collaborate on any of this, again, I laid out the next steps. What we want to do with the samples that we're building are start to insert authorization checks into that orchestration layer. If that's interesting to you and you want to work on it together, reach out to me or hit us up on our Slack channel. You can find that from the website as well. And yeah, if you have questions, I'll be around. Okay, question here.
What is your thought around like Microsoft Copilot, who are like giving it to their customers, and what do you think about that?
Giving what to their customers?
Yeah, because it comes with now the Microsoft 365. So what do you think about that? What kind of issues do you see?
I'm not sure I follow the question. Sorry.
The question is Microsoft Copilot, it is basically AI, and it kind of looks at all the chat or all the documentation that exists in that 365 environment.
And so the question is, what problems?
What kind of issues do you see?
Well, I mean, I think, and I've not studied that in great detail, but I think that again, the access control, when you look at some of these type of issues, like who's submitting the content?
Hey, please keep it down.
Who's submitting the content? Are they trying to poison the LLMs? Like, I don't know what access controls they have around those things. That's something that I would want to look at if I were to use that, and validate that they have these, like they're using this type of approach where they are not only looking at the inputs and outputs coming in, but who is doing it, and are the right access controls applied. I don't know much about that. Like, I've not researched it myself, so I can't answer it. But I would apply that type of thinking to it or question it if I were to go down that route. Yep, question.
In the notion of trusted AI, what's your opinion on model explainability? There's a lot of discussion on model explainability, that it's so complex and the hallucinations and everything. How can we achieve model explainability?
So I think that I don't have like a great answer to that. To me, it comes down to who are you giving access to. That's kind of, again, using like, what are the tools that we know we have available to us today? How do we give very strict access controls to these things to prevent abuse in those type of situations? I think that you're still exposed to like the insider threat situation, in which case you want tighter monitoring on the actual data that's being exchanged at all points of I/O within the LLM. But the way that we're looking at it right now is, hey, let's apply strict authentication and authorization controls so that we can at least control who is interacting with these things versus trying to solve the problem of the what's the word? Adjustment or protection or prevention of the data itself, because we at least don't have an answer to that. And I don't know that anybody does, but it's at least authorization helps mitigate it.
Okay. A little bit differently. Beyond authentication and authorization, how do you detect an adversarial input to a model? Like on the API front end that you build, how do you know on a prompt injection that the input is malicious?
So for now, the best that we can do are look at the materials, or sorry, not the materials, but things like are there IP addresses, are there domains, are there URLs that are being referenced, and apply those against threat intelligence checks. And so that's what we would do today, is basically pick apart every indicator that we could from that IO and start pumping it through threat intelligence lookups to see if that's exactly right. So it's what you would do in call it like an enterprise security environment, but we're applying it at the API layer. And again, to be clear, it's not the silver bullet. It's something that we can do. Yeah.
So for you, for data protection, for input and output, you're using some sanitization, right?
Yes.
What kind of sanitization methods do you use? Like just pattern methods, or are you using another model which will?
Right. Yeah, it's a good question. Right now, it's just pattern methods where we're looking at URLs, domains, IP addresses, email addresses, usernames, things like that. So we use, at least for today, we're using Microsoft Presidio in the back end for matching, and then you could write custom regular expressions as well to match against that data if you want to do something customized.
How big are your library of patterns right now?
So right now, we have like 75 patterns that we match against, that we look for, which is not enormous, but it's extensible so that you could add your own. That's built into the Redact engine that we have today. Yeah, and it looks for things like other things that it looks for beyond domains, IP addresses, things like that are also social security numbers, credit card numbers, other PII, driver's license numbers, things like that.
But like, do you see here some problems because you're using patterns? It's always like based on previous detection, but hackers will try something new, and so you will detect their attacks based on patterns which you're not detected yet, right?
Right. Yeah. So evolving that and allowing it to adapt over time is something that, like, we were not solving that now, but it's a good thing that we have to look at. Okay. Any other questions? I'll be hanging out here if you want to come up and chat more about any of this. And thanks for attending. I appreciate it.